Hey, what's up, guys? Happy New Year. Hope you had a wonderful break. Today we are beginning Unit 5, which means we are halfway through the 8 units that we are going to learn this year. And so Unit number 5 is entitled Functions. And today's lesson is Relations versus Functions. And so in this lesson, what we are going to learn is we are going to be able to determine whether a given relation is a function. Now, you're hearing me say words, relation, function, and maybe you're thinking, I have no idea what that means. I thought this was math class. What terms are you using? That's okay. By the end of it, you're going to see this idea is a pretty simple one. It is going to be there's a lot of language that I'm going to be using at first. So if you are confused at first, I want you to know that is okay. I need you to go ahead and say, that is okay. All right. It is okay if I'm confused at first. But by the end of it, once you see more examples, and especially once you're doing the practice, I think you're going to see that this is pretty simple concept, right? So what are these terms? What are the definitions? Okay, so let me start there. A relation is any set of inputs that has an output, okay? So input, output, X's, Y's, okay? That is how you are going to think about it, right? Another way to think about inputs and outputs is you can just think about something that has a cause and effect relationship, right? Something causes, it has an effect. You know, that's you put something in, you get something out, okay? Inputs, outputs, okay? So for a relation to be a function, each input must have only one output, and that is the key right here. Okay, that's the key. For every X, there can only be one Y. For every X input, there can only be one output. Okay? Meaning, X's can't repeat. So the input, the numbers on the input, cannot be repeated. They can be repeated on the output, but not in the input. And it must pass the vertical line test. Okay? And so, again, maybe that makes no sense to you. That is okay. All right. I think once you see it and see some examples and some diagrams and figures, I think it'll make a lot more sense later. All right. This is a note just to consider. All functions are relations, but not all relations are functions. We're going to talk about that more. Just wanted to point that out, but we're moving on. Okay, so functions can be shown using the following things. You got ordered pairs, you got tables, you got maps, and then you got graphs. And so today, all we're doing is we are just determining, hey, is this relation, is it a function, okay? So let's start by looking at ordered pairs, okay? Now, when you deal with ordered pairs, you always have an X and a Y. The X is the first number, the Y is the second number. The X is the input, the Y is the output, okay? So, again, we said in order for it to be a function, it can only have one X, or for every X, there can only be one Y. So, in other words, the X's can't repeat. So, you got 1, you got 4, you got 5, you got 9. Okay, those don't repeat. You got 2, you got 4, you got 6, you got 8. None of those X's repeat, so that is a function. It is a function. Now, let's look at the next one. You got 6, then you got another 6, then you got 3, you got 2. Because the 6's as the X, okay, because the first number is the X, because that is repeated, the X's are repeated, this is not a function, okay, because the X is repeating. Okay. Let's look at the next one. Table. Okay. Now the table is X and Y. Okay. Sometimes it may have set A or set B. It may not always have those labels at the top, but a lot of times it will. X and Y. Okay. X and Y table. For this, you got 0, you got 1, you got 2, you got 3 for the X's. The X's do not repeat, so that is a function. But let's look at the other side. You have a 13 and you got another 13. So there are repeating x's. The 13 is the number that repeats. So that is not a function because you can only have one x. For every x, there can only be one y. You can't have multiple y's for the same x. Okay? In other words, the x's can't repeat. Again, what I want you to see is the two 4s over here, that doesn't matter. Okay? Again, I'm only looking at the x's to determine whether or not it's a function, not looking at the y. The x's determine whether or not it's a function. Let's look at these maps. Okay? When you have a map, the left side is the input, or the x. The right side is the output, or the y. Okay. So for it to be a function, only one line can be drawn to the other side. Only one line can be drawn from each x. Only one. Now, again, for 3 is 8, 6 is 8, 9. Again, there's no, on this side, the x's are not repeating. In other words, they're not multiple lines coming from the same x. But let's look at this side. For this one, you have, for the output, you got x is 1 and the y is 3. X is 3, the y is 5. For the 5, you have the 5 can be 2 and it can be 4. Again, for this one, there are 2 lines coming from that one x. Again, so it repeats, so that is not a function. It is not a function. In other words, on the maps, there can only be one line coming from the x's. Only one line can be coming from the x's. Only one line can be coming from the x's. And then lastly, we have a graph. And in order to figure this out, you have to do what's called the vertical line test, okay? The vertical line test is, a vertical means straight up and down, okay? And so what you can do is you can make a line, and if at that place on the graph it only touches at one point, then it is a function, okay? So if there's no way, no place on this graph where I can draw a straight line and it touches, if it only touches at one point, then it is a function. Let's look over here. Now, if I draw this vertical line on this point, or on this line right here, what you should see is that this touches my graph right here, and right there. It touches it at more than one point, so that is not a function, okay? Again, it's the same idea, but it's just shown in a different way. Again, this x has multiple y's. It does not pass the vertical line test, so it's not a function. Again, if I drew this vertical line, again, I see it touches my graph, this squiggly line, okay, at multiple points. So, therefore, it is not a function. Now, again, guys, listen to me. If you're still thinking, I heard what you're saying, I don't still understand, that is okay. What we're going to do for the remainder of our time is we are going to do some practice in Delta Math, okay? And you're going to get to go through a couple examples, and I guarantee you, by the end, if you focus and you pay attention to what I've said here and you try to apply it, you're going to see that this is really, really, really simple, okay? So at this time, you can go ahead and glue your notes into your notebook and get started on the practice in Delta Math.